Good afternoon. Am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay.
Good afternoon, sir.
Good
PT
afternoon.
sir.
Good afternoon.
Sir, it is audible.
Now, what about the speaker? Has she joined? No.
Sir, not getting any screen. Sir, speaker কে দেখতে পাচ্ছেন?
Hi, nice meeting you.
Yeah.
Really worried. Good day, please welcome, madam.
Oh,
PT
can I have so many noise?
PT sir.
Yes, please. Good day, Julia. Good day.
Welcome her.
Hello.
Good day, Julia.
Yes.
Good day. This is Paramartha.
Hi.
Right. So now you are fine, okay? So can we start? Can we start now?
Right. And I will share. I will. Yes.
Madam, please try to share your content. Is it coming or not? We can check.
Okay. So I should.
No. Hello. Hello.
Yes, sir.
Can you share your? Yeah.
Yes, madam is sharing content. Is coming.
The file.
It is coming, not yet. Has come.
Yeah.
Yes, it
is coming now.
has come.
Okay.
Hello.
Hello.
So, sir, go. Sir, do the formalities.
Good afternoon. Good day, everybody. So, without wasting any further time, let us. Am I audible by the way to everybody?
Yes, sir. You are audible.
Okay. So, without wasting any further time, let us start because already we are somewhat delayed.
Yes.
So, let me introduce the speaker first. Pau-Choo Chung, Julia.
Yes. Yes.
Distinguished speaker.
Yes.
IEEE distinguished lecturer. So So let me introduce her. She received the PhD degree in electrical engineering from Texas Tech University, USA in 1991. She then joined the Department of Electrical Engineering, National Cheng University, Taiwan in 1991 and has become a full professor in 1996. She served as the head of the Department of Electrical Engineering during 2011 to 2014, the director of Institute of Computer and Communication Engineering 2008 2011.
PD sir actually not audible.
Okay. I can.
PD sir, please unmute.
Okay, so I should start now, right? Should I?
I'm sorry. Let me finish.
Okay.
She also served as Program Director of Intelligent Computing Division, Ministry of Science and Technology during 2012 to 2014, Taiwan. She was the now am I audible? By the way,
Yes sir, yes sir.
and she was the Director General of Department of Information and Technology Education, Ministry of Education during 2016 to 2018. She served as Vice President for Members Activities IEEE CIS during 2015 to 2018. Dr. Chung's research interests include computational intelligence, medical image analysis, video analysis, and pattern recognition. Dr. Chung participated in many international conference and society activities. She served as the program committee member in many international conferences. She served as the publicity co-chair of WCCI 2014, SSCI 2013, SSCI 2011, and WCCI 2010. She served as an associate editor of the IEEE Transactions on Neural Network and Learning Systems during 2013 to 15, and the associate editor of IEEE Transactions on Biomedical Circuits and Systems. Dr. Chung was the chair of IEEE Computational Intelligence Society during 2004 to 2005 in Taiwan, Tainan chapter, the chair of the IEEE Life Science Systems and Applications Technical Committee during 2008 to 2009. She was a member of board of BOG of CAS Society during 2007 to 2009, 2010 to 2012. She served as an IEEE CAS Society Distinguished Lecturer during 2005 to 2007 and the chair of CIS Distinguished Lecture Program during 2012 to 2013. She served on 2 terms of ADCOM member of IEEE CIS 2009 to 2011 and 2012 to 2014. The chair of IEEE CIS Women in Computational Intelligence during 2014. She is a member of Phi Tau Phi Honor Society and is an IEEE Fellow since 2008. So we heartily welcome Julia, the speaker, to deliver our distinguished lecture. Welcome, Madam.
Okay. Okay. Can you hear me? It seems that the communication network is not good enough. I'm not sure if you can listen to me well or not. But anyway, I'll try my best. Yeah, my talk is about the deep learning networks for medical image analysis, its past, future, and the issues. You know that recently, because of the deep for example, we have seen here are the deep learning networks used for general object detection and recognition. And there are many of the deep learning network has been developed. The early part is like fast RCN, YOLO, and the various kind of network, and they have achieved very excellent performance in object detection. And recently, because of this success, it has been used in medical image analysis. This one shows the YOLO, the detection, and in various image understanding. So this kind of model has been developed and modified, being used in neural networks. Compared of the computer vision, as we have mentioned in the few slides before, medical image analysis actually has adopted the neural networks. That means artificial intelligence for medical image analysis for a very, very long time before. But traditionally, this is one of the basic way traditionally it has been used in medical image analysis. That is, the first thing you have to extract some of the features. For example, if we would like to detect the tumor from thyroid and non-thyroid regions, and you will try to, based on the image, you will try to extract the feature from the image. For example, you may say that, because the image energy or homogeneity or the variance or the dissimilarity, there's kind of feature. This kind of differentiation. Because of that, we usually will use the image analysis to extract the feature. We call artificial intelligence to do the classification. And this is one of the examples. For example, even for this topic, it has been it's still been developed into the endoscopy image. And if there's lesions, what kind of the disease would the lesions be? So usually we will go this way. That is, for the image, we will extract the features. And there are many, many kind of features. And this kind of feature, we call it hand-on features. For example, you might think that because of and the color may be a little bit more kind of tend to be red than the normal tissue. So you will extract some of the color features, and you may extract some of the texture region in there. There will be the scar on our body or our feet, on our tumor. Much more rough. So we will usually use lots of mathematical way. For example, wavelet transformation is one of the way, and the texture color. And we will, based on this feature, we go through lots of statistical approach to see whether from this color or texture or the wavelet transformation, we can do some of the extraction and do statistics. But because of that, because we don't know what kind of feature are exact feature be effective. So sometimes we will go through the feature selection. The feature selection is one of step that is to select the feature which are critical for this differentiation this region from the normal region. So we will do we so-called feature selection. That is to select the dominant features from those. And then after we get these features, we'll go through the classification. And then in this, the traditional way, we usually use a support vector machine as the classifier. And then after that, you can say that, once the support vector machine, then I would think that is a region or a suspicious region. And if it is lower than a threshold, then we'll say, okay, that would be normal. So we will usually use sometimes that cognition. In this way, usually we need to decide what kind of features we want to endoscopy image. It may be, we may say that, well, if the image is turned to red, so you need to know this information. And so, so this kind of feature has, and then based on that, you do the selection. But now the deep learning, it says that maybe there are some of the features. It is hard for our human to get this feature. We don't know. Maybe there are some features it's hard for us to describe. So we would like the network to learn and to extract the feature then automatically. So that is what the convolutional network comes out. And the early stage, actually, convolutional network is come through a very early neural network model called neocognition, which is probably 1960 something, very early. This kind of network is kind of, and you go through one of the a layer, and this layer we have the mask, and then to look into the images, we have one mask. This is so, and then after that, they will followed by a we call synthesize the layer from there to another much more higher features, and then goes to repeat it, goes to another like our current. And for example, this is one of the results. They designed the layer to extract the features, and then another layer to try to convert this layer, the figure, the number into the field. That means this layer will go through a feature and then finally do the classification. This is one of the approaches. For example, this 3D feature, they will go through there to say that, oh, this number. They try to code this number into a specific characteristic layer. For example, like you will kind of to design this network architecture like this and go to the layer. So even though the early stage we have the cognition, shape cognition, but it's still we still need to kind of to code this into another. For example, they may say that if your code number is number, it represents a certain angle. If it is this, that means the region is much smooth. So you need to code this. This is early the way of doing that. So you try to code this, and you will say that, oh, this number represents the irregularity. Together may represent the elongation. That means the region looks like a little bit longer. And if you have the number like this, you see that whether this feature represents the feature is tend to be very circularity. That means it's tend to be very looks like a circle, very round. And this is a companion. So you will go through these kind of features. Even currently state, we have the deep neural network still come out these features for them. You use this kind of number to code very long. For example, this is a little bit long, and or this bit longer, and if this do that. And this kind of feature, we call it handcrafted features. Handcrafted. And recently, even before up to recently, still, doctor like this kind of feature. And they have the term called this feature, called biomarkers. Biomarkers. That in the diagnosis. For example, they would say that as long as this number is larger, that represent this rough. The much rough, that means this tumor is much malignant. It's not so benign. That means it's much better, much worse. This lesion is worse. It's malignant. Okay, and so they use this kind of feature as a core biomarker, and it has been used in clinic for a long time, and all the research are looking for the biomarker. So looking for a biomarker in the medical domain is very critical. That means this kind of a sign, this kind of number give you an indication that it could be a tumor, or it could be this certain kind of disease, and we call it biomarkers. But now I have shown here, this is a very traditional convolutional network. We give the image, and we give lots of convolution layer. And each look into the image. Can you hear me?
Yes, ma'am. Yes, ma'am.
Yes, yes, we can hear. Please.
Okay. Okay, all right. All right, thank you. Thank you. Use convolution mask and look into the images. One window after. See this many plane. Each plane, we call it a feature plane or feature map. That means this feature, this convolution mask, is trying to extract certain kind of properties of feature planes. And then after these feature planes, you go through the next. This area. In this area, then you will go through the region here, and all the feature plane will go release, and then you will compute the future here. So again, the next layer you have lots of the convolution layer again, and then this result will go to another convolution layer, okay, and another convolution layer. But sometimes it will go through a pooling layer. So pooling layer, I don't know. I don't detailedly talk about the convolution layer. You will compute the image with a weight, go through the network here. But for the pooling layer, instead of go through there, it try to find the maximum line. So after that, it may go through a maximum pooling layer. This maximum pooling layer will find the feature from within a region and find the maximum data, because the maximum data usually means the data has some of the spatial indication. So you go through this way. Okay? And then finally, the last two layers are the fully connected layer. Everyone. For here, each neuron connect to a small region only. For here, this only, we call it convolution layer. But for this layer, that means will look into all of the data here, and then finally it will go through the decision. the output. Okay, so this is the final layer, and then for each convolution layer, all fully locally connected. But the softmax, it will connect to all. It will connect to all. And the someone come out. If you look into the convolution there, will be like that. Will be like that. That means in this area they have some small spatial response. So this. So because this convolution, this does not know that has been extracted because you don't design the feature. It is never automatically extract for you. The feature it has been extracted from the image. So some say you will get lots very discriminative. Some may be non-informative. But in our process, we all send it into the next layer, the network to do the process. Of course, if I do feature are more discriminative, what feature are non-informative? You can remove. It will help you to improve the network performance. But currently, not many of people, they just get it into the neural network and to do it. So if you talk about the neural network, normally this kind of approach has some of the problem, like whether it's interpretable in terms of diagnosis, because doctors may not know what kind of feature you have. And so sometimes the doctor will feel a little bit about whether it's trustable or not. So this is one kind of issue here. But from our perspective, research recently talking about whether the image can become interpretable, whether we can get the feature is interpretable. What that means, whether I can know I doing and what are the results. So that will give the doctor much more confident about the results. So this is trust. Even though this is an issue, because I kind of talk about, if you are a student, this moment I would suggest you don't worry about this, because as long as your performance is high enough, then you can say that, you see, our sensitivity or our accuracy can achieve 95%, 99%, then that is the good number for you. It's at this moment it's hard for you to touch this issue, but I'll tell you this is one of the issues that is on research recently. And another issue is, if you like to do this research, you need the ground truth data. Ground truth data is that means if given tumor, you need to know where tumor. So you need the ground truth data. This ground truth data for neural network to do the so if you're working on medical image, you need to get you are contacting the doctor. This is the difficult part you need to conquer, because you need to consult with data. Doctors are very busy. Data. It's not as you say this is, but if you like to mark the region, you need a doctor assistant, unless the region is very obvious. Yeah. So if you want to do, and because of that, you may not have enough of the data. And in case on that, there's several ways you can do. One is to do the transfer learning from other medical, from general imaging, or based on some effective tuning method. That is, you get a model which is working on other purpose. And you get this model and you retrain this model to fit into the data on your hand. This is one of the example. Is try to detect the poly. That is that they would like to detect the poly, like here, okay, like here. They would like to detect this poly, okay, and but to do the test, whether we can do the transfer learning from an existing image. This is a network that have been used. As I have mentioned to you, this is the image and this is the convolution there, and then convolution. And finally, usually there will be multi-layer. Is a teaching. So you get a network from AlexNet. This is a very common network called Alex. They use this AlexNet, fine-tune this AlexNet to fit on poly detection from column images. They said that you know that if this is the image and this is the output of this model, so answer is correct or not appears here. That means correct or not. The feature here, on the feature here. But they said that if you can tune the network here from the later layer to this layer, and then this, instead of start from beginning, then you will get a table, and it shows that you try to tune from this layer and then to the into, and how will be the result. Okay, this is show you the poly detection rate. If it is, you may get this, and you use the AlexNet, start from scratch, start tune. Only the last layer, it will be here. You fine tune 2 layer, it will be here. You fine tune from in the early part. If you want to get the good performance, if you find the data, the model, instead of start from scratch, you will get. If you don't have that much of the data, get much better result. This is some of the performance it show you. It says that if you only have 25% of data, if you get fine tune, you will get here, but you don't data. But if you have more data, you're getting closer and closer. So in case you don't have that many of the data, one approach is try to transfer learning, fine tune from other model, and then it will get you better. Of course, if you have very sufficient of data, then there will be not much difference. the difference will be not much. But if it's hard for you to get that many of data, then you can fine tune from other model. Okay, so that says. And another way is to do the data augmentation. That is, you try to rotate your image, try to flip your image. So one image, you try to rotate this image a little bit, shift a little bit, or you try to change the color, change the intensity a little bit. So you 10 image or 20 image, then you can generate your data. These data are also help if you don't have that many of the data. That will help. There are also some of approach using GAN. I don't know if I think probably many model called GAN, Generative Adversarial Network, which is try to use general noise and generate image, generate an image. So they use, someone also use this to generate new image for it, but I'm not sure, is it that okay? But according to the literature report, they said if your data is not enough, it's not that many, then you use again to generate some of the image for you, it will help. And another is to use the information from different slides. It's a tomography. Yeah. Computed tomography, this is particularly to detect. This is a spine. This is spine on our back. So this is one example we have done in here, and from there to extract the tumor with, and here is spleen, and here something like that. Object identification from a series of the image. In this slide, and then you will take another image in this slide. You will take another image in this slide. So you will take a lot of image in this slide. Sequential organ is here, liver is here. If our liver is here, then you know that if this slide can see the liver, the next slide will be able. The next slide will be also this, we call it sequential information. Or in the reason I start here, take the liver, you can see this liver has a very large region, so it's easy for me to detect. It's easy for me to detect. The liver, this is also a liver, but if you would like to detect a liver from this slide, it's much more challenging because here, and this is kidney here, this is kidney here, so there are lots of the interference here. So in that case, I would suggest that you start from the slides, as I mentioned previously. You start from the slides that is most easy to get. And then because your organ is, because in slides to another slide, they have so contextual information. That means once I know that in previous slides, if I know that liver is here, then next slide, the liver should be in this region. You will not go through to here. Or you will not go. So you can use this contextual information. And because of that, so we this work actually has been done very quite information into the network and try to each network layer try to extract one slide, and I have one slide connect to another slide, and showing that if this slide has, if I have seen the liver in this slide, the next slide will be have a high potential. I will see the liver again in the near region. So I try to use a network to learn this contextual information and build it into the network model. Then it will help. And this is a network we have been used before. And you can use this concept even in currently the deep neural network, because currently there are lots of ways doing that, but I found out that not many of the research, they research. So this is what, if you are interested, I told you that would be a new idea, even though we have been used at that. But we haven't used it in deep learning network. We use it on traditional traditional neural network. Showing how you use the contextual information, and I designed. So if you I to J is very close, then I will have get higher weight. So get higher weight. This I here, you have one slide here, slide by slide. This slide may be I, and then the next slide be J. So between this slide I and J are the two slides are far away, then the weighting, the information you give me is much smaller. I will set it much close to me, then your information are important to me. So you can build this concept into your network, okay? And another information I have been used is to use spatial information. Fuzzy location, spatial location descriptor. What is that? As I mentioned to you, this is liver, this is liver, this is spine, this is. If you like to detect the organ, if this is the kidney, this region will not be the kidney. The kidney would be next to the spine, the right and the left. The right and the left. The spine and the right and left. Kidney should be here. Kidney will not be here. Kidney will not be here. Liver will be here. Liver cannot show here, will not show here. So these are very standard information. I call it spatial information. So I build the spatial constraint into my network model, so that the network will tell me that this is a liver, because the liver will not come to here, and that this is a spleen. Okay. Go to the spine, kidney, and I try to build a spatial constraint into my network. Okay. So this is location is spatial constraint, and in this CT image location marker, that means all location are referred to the spine, because it is very bright. It's very bright. So you can detect this spine very easily. You can detect this spine very, very easily. So once you get this spine, then all the location. And this is then identification, and to show whether you are on the right or left, like that. Okay. And also, I also use some of it like that. So if this is kidney is wrong, is tend to be wrong, very compact in the image. So you feature are little features, but they are if you like to do differentiate some of very challenging parts, it's very. Another example we have do for the mammogram. Two view of the mammogram. So this is one is CC view, it is ML view. So I try to identify the same. This region fusion and even do the 3D reconstruction. So this is also this is some of our results. To detect this small part. This is micro calcification. This word, micro calcification. Okay. Indicator whether it will become the breast cancer. So this is also another research we've been done. And there's I use this one to tell you that there's another issue that sometimes you will find out. For example, this is MR images. This is MR image of our bone and knee. Our knee is here, and it cut the MR image on this direction. This is one is on this direction, and this is on this direction. And you can see that these are bone. These are all bone. Because this is our MRI. MRI is a magnetic. The image are generated from the magnetic effect. So you can see that in here it is much brighter, and then here it become much darker. So some you can see that this ringing here, ringing here. So sometimes they have some of the ringing you have to conquer in medical imaging. But this is only for like a magnetic image. You would not have like the breast, they would not have the ringing effect because this is X-ray images. So close to like a MR image, especially is on bone images, then this magnetic field will generate this ringing effect. So in that case, you have to worry this ringing effect. Some people will use some of the small things. And then finally, I would also talk you a little bit about some of the research, some of the new research I've been doing, which is the pathology image. Doctor looking into the pathology image. Pathology is the doctor take a tissue from the human body. For example, if patient goes through the surgery, then the tumor will be taken out. Cut a slice of the tissue. Actually, it goes through and then the whole process send the image and then to put it into a slide and go. The doctor or the pathologist will look into to look at the slide and to see. Sorry， 待会再打给我。哎，那10分钟以后，好，我正在 talk。好，好，待会，拜拜。In Taiwan, this is the problem. Okay, and so the doctor. Sorry, my computer. Oh, doesn't. Yeah. This is one of microscopic image. This is one of, and this image is, and this the one you see. They have a different resolution of the the lens. They have 2.5, 5, 10, 20, 40. They have different magnificent scale of the. So the doctor has to look at this high resolution. This the cell level because able to get this broad view of this tissue. If you want to look at the broad view of the tissue, usually the doctor would need quite some time in diagnosis. And then like these are tumor area. That. This is, I show you what are the problems here. The word has, anyway, it's depending on the experience. It highly depending on the experience. On the diagnosis, different pathology, they have give different results. Sometimes you have such image site, and you need to observe different magnification of the images. So, but the pathology image, we call it personal medicine. It's one step because it goes through so the tissue level, you know, usually we go possibly need to further examination. So I don't know. So observation to do the image analysis. And these are some of our results stand by HE tumor here, and try to see how serious is the tumor. And this is tumor. We try to detect this tumor region and try to do analysis of this tumor region. These are some of the results that we have performed to detect this tumor. Okay. And this is some of our results. So recently I'm also doing that. We have been doing. This is ground truth, and this is the result we have obtained. Finally, I would like to tell you that there are some tricks we can use for improve your medical image analysis. Reduce the region ambiguity. For example, I've mentioned limit the process within the restricted region. Adjacency and that will help you, and you can take apply information. Apply information, that means you already know. Based on the clinics, you already know there are some information you can use. And if you and sometimes like I have mentioned to you, use a landmark as the guidance, like the spine as the guidance, then it will help you. Another one I haven't talked to you is cost to find. That means sometimes you can try to use a cost level. You can go through the fine detail level analysis. And that also. Okay, I think I'll stop here. Oh, okay. So finally, I think in medical, currently deep learning, there are lots of the research and the focus. And there are some of the we need to have a complete evaluation, convincing the doctors. Explanation so that can important. And then finally, recently I'm talking with our hospital in Taiwan. We are doing the result with workflow integration. That means our analysis tool should be so that the doctor can use during their daily analysis. So they don't have to switch from one computer to another computer. That way, then it will also help. Okay, thank you.
Thank you, Julia.
It's not.
Thank you. Hello, can you hear me? Hello.
Yes, sir. You are audible, sir.
Yes, yes.
Thank you, our distinguished lecture
Yes.
speaker. Julia, thank you very much. So now there may be some questions. Let us open it up to the audience for any questions. And
Would I be able to?
Hello. Sir, there is one question, not a question actually, that's asking that someone that Amit Ghosh Roy asking that may we get these presentations for better understanding? Madam, please.
Here, right? Participate.
hello.
Is a question in the text?
Yes, if you have any questions, you can type here. I will read it. Madam, someone is asking for your presentations. Will you allow to share it?
Yeah, I have a
Hello.
hello. Hi.
Yeah. Can you hear me, please?
Sen. I didn't see the I'm looking at the text. Can you see my screen?
No,
Can you
some
see
of the
my screen?
participants, there is a request. Some of the participants, they are asking if it is possible to have your,
Okay. What are the
maybe
algorithm?
in some PDF format or some, I mean, whatever, in whichever format it may be. But if it is possible to have,
Okay. Okay. Now let me answer your question.
yeah. Any
Okay.
other question, please? Any other question?
Okay.
Sir,
It's
yes, Rajashree Saha asked Madam that what are the algorithm used to extract the features and how
yes.
can we implement through the programming?
Okay. It depends on what kind of features you will need to extract. If you try to extract through the deep learning convolution network, there's no algorithm. It's the network architecture is like that. Let me extract another file for you. Let me get another file for you. Then you probably let me get another file for if it is let me see. Maybe this one. If it's convolution network, it's just convolution operation. Yes, I can show you. This is convolution operation.
Madam, share your screen, please.
That is, yes. So you just use a mask onto
Hello? Hello?
this mask.
Hello,
Yes.
Julia? Hello?
Yes.
Can you please share your this new slide?
Screen.
It's not
Oh, share
visible.
my screen. Oh, okay. Sorry.
Yeah.
I didn't know. I didn't know that it's not sharing. Okay. Did you see?
Yeah, now it's coming.
Okay. And this is this is convolution mask in the network. So the learning is to learn the weight in this convolution mask. It's like that. This is zero padding. Yeah, this is maximum pooling. And this is convolution. That means for this for any piece you have, you know, do you know the neuron is like that? That means this neuron, this is, and then do this neuron's output. So in the convolution, each neuron operation like that. And for the neural learning, we are trying to learn what are the W1 to Wn. This is the image. This is the image. And this is the parameter you have to learn. This is the parameter. These W are the parameter you have to learn. And in the convolution network, except that this region. That means this region has 3 by 3, it's a 9 position. So I have the 3 weight. I've mentioned to you X. And then this is the weight. This is called convolution approach. These are very basic. So I didn't talk about that unless you want, if you need a very basic learning, then I can lecture. Is way. I learned that this way. So you will get one. You can depending on what kind. Whether it is red, then we in the image there is RGB component. R is the indicate the red component. Then in that case, component compared to R, G and B. So I've divided the red R divided red R divided based on the number. I do the statistic. So the algorithm to extract the feature you want to extract, you need to use the different algorithm. So the algorithm which classifier is suitable for a particular data set is then automatic system to choose best classifier. Okay. Classifier. I don't know if you talk about the neural classifier. There are various kinds of classifier. There are neural network type. Neural network type recently handcrafted feature and go through the neural network. Then currently through the new learning, then usually the network model is like I have mentioned to you, like I have closed it. As I have mentioned, layer after another layer, one layer after another layer, I have closed to you. That's okay. Okay, come back. That is the one. That AlexNet. That's a different kind of network. To do the classification. If you want to do classification, then I would suggest maybe I type here. And maybe I can type here.
Madam, can you hear me?
Yes, if you want to do the disease type, I would recommend like a ResNet. If you want to do the segmentation, then I would recommend like UNet.
Yes.
UNet
Madam,
is
one
commonly used.
participant.
Yeah.
Yes, yes. Madam, one participant, Joyati Mukherjee, asking you that can booster help to increase the efficiency in case of medical image classification?
Boosting, right?
Yes, booster.
Booster. Booster.
Yeah.
Yeah, you are talking about with the ADA booster like this kind, right? The boosting. Yeah, I think it will help. Boosting, yes, it should help. It will help, especially for those some of the cases that are very challenging. Then the boosting will help. Especially you have different, then the boosting can help. But boosting usually they come and you boost it. So yeah, of course. Then probably you don't need the boosting that much because boosting usually are used when the network are relatively high would help you because it use kind of the few. Any other
Madam?
question?
Yes, madam. One question that for medical image segmentation, so which classification type? That means semantic segmentation or instant segmentation? Yes, normally used.
Normally used segmentation. For segmentation,
Yes, of course.
for segmentation, there are several have been used. Some use unit. Some use unit.
Yes, madam.
Yes, some use unit. Unit is quite commonly used. Of course, there are lots of the new network model being developed. My student also use ResNet, but unit is the one that's most commonly used. Because you consider some recently some also called DenseNet come out. So, but UNet is up to this moment is still very common. It's very yes.
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 So, madam, in case of segmentations, for instant segmentation or just semantic segmentation, which one would be the appropriate for medical image segmentations? Semantic or instance?
Semantic, you need to do also classification. So yeah. Is to page alone. Everyone is asking whether you apply the geometrical feature. Hello, can you still hear me? Some
Yes.
the question is
Yes, someone is asking is generally
something on
apply
medical
segmentation.
image.
Yes.
Usually we apply segmentation before. So my question is to in which alone to look at geometric feature alone. So your geometrical feature usually what kind of feature you will get? Architecture. I don't know if it be normally if you do the disease classification, usually they will look into the texture. So it's hard I use something like try to maybe angiography, that is to look at through the vessel, the vessel, look at outside. They all angiography will go through to look at into the vessel to see whether the vessel has whether it has whether there's some of the collagen stuck in the vessel. In that case, they will need to look at the way the vessel going through your body. Probably they will need they will not need the texture. In that case, and what else? Air convex hull, like that. Sometimes if some of that region then convex. But you say all along. We are doing the breast cancer, the boundary roughness, and to see whether there is some convex hull there. But use other features. So you can use this geometry with other features. Maybe I would see that question in general which feature.
Is there any other questions? Okay, madam, just
I think there is no other question.
yes, I think there is no other questions. Okay,
Okay.
so Nusmita madam, do you hear me?
Yeah. Okay. So
Hello.
Yes.
Yeah. So thank you very much, Julia, for being with us. It was really a matter of pleasure for us that you shared some of your latest findings. So we got enlightened, and there is definitely knowledge addition which will be helpful for all of us to, augment further in our research and other activities in days to come. So thank you once again. A very, very, words of gratitude from our end, and we hope that the collaboration is the starting of collaboration. We may have other collaborative activities in future. So yeah, thank you very much. Thank you very much. So we'll be in touch with you. Rest assured.
Okay.
Yes, sir. There is a letter of appreciation at there. We want to share with madam.
Is it possible to share? Is it possible to share? Yeah, here.
Yes, sir. It is possible.
Just share. Just share.
Yes,
Julia,
yes.
please wait for a while.
Yes. Is it visible, sir?
No, it is coming.
No problem.
Just wait. Yeah.
mean the guide.
So,
Okay.
on behalf of IEEE Computational Intelligence Society Kolkata chapter and
Me.
Banga University,
Actually,
so there is a small, token of appreciation from our end. Uh, so this is just a, small gesture from our end. Okay. So thank you for once again for all your cooperation and your sincere effort. So thank you.
Okay.
Thank you very much.
Thank you.
And
Thank you.
right now there will be a vote of thanks. Okay. So
Yes.
we shall be in touch. Thank you. Yep. Now there are some other
Okay.
formalities
Thank you.
left before we finish up.
Okay.
Thank you. Thank you.
Okay.
Thank you.
Okay. Okay. Thank you.
Any other?
So-
vote of
Okay.
thanks or anything?
Devasmita madam, are you there?
Yes, I'm still here.
No, actually, I'm asking madam, our colleague, for just giving the votum tag.
Okay. So I can leave now, right? Can I?
Yeah.
You may.
If
You may.
you is,
You
yes,
are
yes.
at liberty. If you wish, no problem.
Okay, so I can leave now. Okay, thank you. If you need
Thank you.
any
Thank you.
information, you just send the email to me. Okay.
Sure.
Okay.
Sure. We'll be in touch. Thank you. Bye-bye.
Hello.
Hello.
Devasmita madam, are you listening? Sir, I think she getting some problem, connection problem.
No problem. If you have, from your end, if you have got anything to say, just say a few words and then I will sum up at the end.
Yes, and I would like to thanks to everyone, every participant, especially the speaker and the other delegates such as the Susmita madam is also here, and the other faculty who are just help us endlessly. Few are named there, Dr. Somnath Mukhopadhyay, Radhakrishna Bora, they are from Assam University. Without their technical help by providing this kind of this platform, it would not possible. So I would like to thanks to them as well as all the participant and our universities, especially that our vice chancellor sir, register sir, especially sir, PD sir, you that your enormous enthusiastic, we are able to organize such kind of events.
My
So
pleasure.
yes, if there is a Devasmita madam are there, then she can give the vote of thanks on behalf of us. But probably she is getting some problem.
So I think there is no further wasting any more time. So
Yes,
dear participants, my dear participants, let me share some of the agony. I hope that after understanding that, you will be able to appreciate what exactly went on. So initially, the IEEE gave me the impression when I was communicating to have the distinguished lecture program here. So initially, they committed that there will be this Zoom platform they will provide, and accordingly, just before the commencement of the program, DL program, it will be provided. So accordingly, day before yesterday, I started communicating with them, the persons, the IEEE CIS headquarters, and only day before yesterday, we came to know that that facility is no more there. So the the host and the local chapter has to arrange for the for all the online platform that they need to use, and we have got very little option at that time. Frankly speaking, at the evening of day before yesterday, I came to know personally, and then only I had to arrange everything. I mean, great thanks to Assam University Shilchar, particularly Somnath, who came to rescue all of us on this occasion. That it's basically their their subscribe platform that we could use that. Without this, I don't know what would have happened. So because of this, I mean, there was hardly any time to reorient ourselves or reorganize ourselves, better to say. So within that short span of time, whatever we could do, we did. So some of the inconveniences are there, I understand, and on behalf of the organizers, we sincerely apologize for that. And hopefully, there are two more distinguished lectures. Those are going to take place. One is on the 6th of November. You may write it down. One is 6th of November, and another will be on 22nd of November. So two more distinguished lectures are going to take place, and hopefully this type of inconveniences, whatever caused this time, will not be repeated. We shall try our level best to arrest this. Okay, so otherwise, thank you for all your cooperation. In fact, apart from the apart from the organizers and the resource persons, it's ultimately the participants who are the biggest stakeholders of such an event. In fact, without them, it's meaningless to organize any event whatsoever. So, with their evergreen cooperation, it has come to, I mean, such a success, and we are really thankful to all the participants. And as such, there is nothing more to say. So, in due course of time, I mean, there will be programs, technically sponsored or technically organized by IEEE Computational Intelligence Society Kolkata chapter in days ahead. So you will be informed. All your email IDs and other contact details are with me in our database. So you will be informed. And I mean, if you feel that it is important to you, please, you are welcome to participate in future also. Make those events also a success like this. There is nothing more to say. Yeah, I mean. Hello.
Okay, sir. Yes,
There are
we're hearing you.
Abu, there are some
Yes,
questions
sir.
in the chat box. Please try to address them individually if there is any points of merit. Then please take
No,
care.
sir, there are no questions are there right now. But
There may be some
some,
observations there. There may be some observations there.
yes, some observations are there. Okay, so no questions are there right now.
Yeah. I mean, just try to address them as far as possible.
Okay. Okay, sir. I have mentioned the feedback form where they can mention if they wish to ask something or want to say something about this event. They can put their thought in feedback form also.
Sure.
Okay,
So,
we'll
I
take
mean,
this.
any apart from the feedback form, formal feedback
Yes,
form that was provided to the participants for their
yes, sir.
opinion or feedback, whatever.
Yes, sir.
If any participant has got anything to say, I mean, now maybe
Yes,
one or
sir.
two.
So right now I am unmuting all of you. Okay.
Yeah. So if you have got anything to,
I have unmute all of you. If someone is want to say something, then you can ask.
Unmute করতে
Yes,
বলছে।
sir. Yes, sir.
ও এখনো কেন আমাকে
I think Google form would be better for addressing this kind of thing.
so let us find the right. Find.
Yes.
Thank you once again. Participants, all us. Anything more to deliberate?
No, sir. So this moment, I think that we are ending this
Okay.
event. Okay, and
So
we'll see.
let us end this event. I
Yes.
think there is no point in prolonging further. Okay. Thank you very much once again, all of you. Okay.
Okay. Thank you, everyone.
Sir, can I end this meeting here?
Yes, sir.
Yeah,
You can leave it if you wish.
please do. Bye-bye.
Okay.
Okay, kindly submit feedback form positively. Okay, based on your data collected from this form, the certificate will be generated, and the certificate will be shared with you within a week.
Okay. Abu da end করব তো?
Okay.
Yes.
হ্যাঁ তুমি রাধা ই করো এন্ড করো
হ্যাঁ, okay.